Let's develop your intuition a little bit more. We'll use this hypothetical DAG. Now suppose the DAG has work W of n and span D of n. The ratio of work to span, or W divided by D, has a special interpretation. It basically measures the amount of work per critical path vertex. So think about that for a second. At every critical path vertex, there's an average amount of work. So this ratio basically tells you the average available parallelism in the DAG. So imagine you're a critical path vertex, like, I don't know, say this one. When that critical path vertex executes, there's going to be a bunch of work sitting around, and on average, the amount of such work is W divided by D. So what does that imply? Suppose I give you a PRAM with P processors. How many processors should you use? It looks like it would be nice to have about W over D processors. And if that's the case, you can basically keep the processors busy on average. Work and span give us some more information. You know, for example, that the span is a lower bound on the execution time. You're going to give this a special name. We're going to call it the span law, punishable by death. Now that's a lower bound in terms of the span, but it's not the only lower bound. Another scenario I could imagine is just taking all of the work, and if there is no critical path, then I would just divide that work evenly among the P processors, and that would give me another lower bound. Basically, the ceiling of W divided by P. And we'll give that an ominous name as well, the work law. Now I have a pea-sized brain. I don't like remembering all these laws, so I'm going to write this more compactly. Both laws hold, so I can combine them. Basically, the two laws have to be true simultaneously, so I can combine them. So remember, W over D tells you the average available parallelism, and W and D together, given P, gives you a lower bound, which is this combined work span law. Commit these to memory.